This is a screencast on balancing redox equations, and we're going to use the half-reaction method to balance redox reactions. Right, and this involves treating, on paper only, okay, as two separate processes. Okay. And we're going to balance them and then combine them, a lot like Hess's law, to attain the overall balanced equation for the reaction. Alright, so the first thing to do in this half-reaction method is to assign oxidation numbers to identify what is being oxidized and what is being reduced. Then you're going to write those as two half-reactions, the oxidation reaction and the reduction reaction, and that would be separately. And you're going to balance each half-reaction, focusing on the elements other than hydrogen and oxygen. Then you're going to balance the oxygens by adding H2O to the side that is deficient in the number of oxygens. And you're going to balance the hydrogens by adding H+, the hydronium ion, to the side that is deficient in the hydrogen atom. Look at the charge on either side, the products versus the reactants, and balance the charge by adding electrons to the side that is more positive. Once you do that for each half reaction, you're going to look at the number of electrons gained in the reduction and the number lost in the oxidation reaction. You're going to multiply the entire half reaction by an integer so that the number of electrons gained is equal to the number lost. Then you're going to add the half reactions and subtract things that appear on both sides. Double check when you're all done to make sure that the equation is balanced according to mass and also according to charge. The charge on either side of the equation must be the same. Right, so let's take a look at an example of balancing a half reaction. We're going to look at the permanganate ion, MnO4-, and the oxalate ion, C2O4, -2. Here is the overall equation. So the first thing we do is assign oxidation numbers to determine what is being oxidized and what is being reduced. If you have trouble assigning those, please see me outside of class, right? The manganese here is going from a +7 to a +2. It is being reduced. That means the carbon must be oxidized. So we're going to write the oxidation half reaction, that oxalate ion going to carbon dioxide. To balance the carbons, we need to put a coefficient of 2 in front of the carbon dioxide. The oxygen is balanced because I have 4 on both sides, but my charge is not, so I have to add the 2 electrons on this side to equal the 2 negative charges on the reactant side. And my oxidation half reaction is now balanced, so we're going to move to the reduction half reaction. The manganese here is balanced, but the oxygen is not, so we add 4 waters to the side that is deficient in this oxygen atoms. Okay, so now I've got to balance the hydrogen, so we're going to add 8 8+ to the reactant side to balance that out. Now we're going to look at the charge. To balance the charge, if you notice, I have 8 positives and a negative on this side. So on this side I am +7 overall charge. Here I am +2. So I need to add 5 electrons to this side so that together it is a +2 and the charges are equal on both sides. Now, let's look at these two half reactions and see, hopefully you can see that the electron numbers don't match up. I have 2 electrons being lost, 5 electrons being gained. I want to make these the same, so I'm going to have to multiply this first half reaction by 5 and the second one by 2. Now I can add these together and then cross off things that appear on both sides. If I look at the things that appear on both sides, it is the 10 electrons, and that should be it. So then my final reaction is just copying over the things that are not repeated. There's an example. These are balancing in acidic reaction. If you notice, in this balanced chemical equation here, I've got the hydronium representing an acidic solution. Even if this appears on the product side, it is still being considered as being balanced in acidic solution. Sometimes you'll be asked to balance an equation in basic solution. That's fine. Do the same process as if it occurred in acidic solution. So the same process that we did. Once the equation is totally balanced and you've added everything together to get the overall equation, we're going to add hydroxide to each side to neutralize the H+, and that creates water in its place. That concludes this screencast.